Hello, good morning everyone. Today we will be doing with the virtual work method for calculating the deflection and slope. So in this method, I have already told you you can take this method in the, you can also say that it is an energy method because we use strain energy formula in this. So today let us write virtual work method. Okay, so in this method, or you can say unit load method. Okay, unit load method virtual work, because in this we will be applying a uh, load at that point for calculating the deflection which is not there, and we will be putting the value of that load is equal to unit. So that is why we are also telling this method or calling this method as unit load method. Okay. So suppose there is a beam. Uh, so for example, this is a beam, cantilever beam here, okay, and you have to calculate the load at this point. For example, it is having a UDL, okay, and you have been asked to calculate the unit load at B point. So how will you calculate the deflection at that point? So in the virtual work method, first of all you have to apply a unit load at that point where you have to calculate the deflection. So earlier this load was not there, but I am applying a unit load here, that is P. First of all I am taking this load as P, okay, and you have to calculate the moment generated due to the original external loading that is given, and this is small m, which will be the moment generated due to this load we have applied. That is the virtual load, or you can say unit load. Okay, so the formula for calculating the deflection will be unit load into the deflection equal to the integration of 0 times the length of this beam, or the span that you are taking. Suppose if it is having a b c d and so on like this, so you can integrate span wise also. So 0 to L, capital M into small m into dx upon ei. So this is which method? This is the formula for strain energy only. I have told you that this is the formula for that was mx dx upon 2ei, mx squares. Okay, so while differentiating this you will get that 2mx upon 2ei. Okay, so 2 cancels out and it remains mx, so here it remains del mx upon dx. So this is taken as a small moment, that is m, that will be according to the unit load, and capital M is this value which is due to the external loading. So this is why we are calling this as a energy method also, because we are using strain energy formula in this. So for calculating the deflection, you have to apply this formula, and if you have been asked to calculate the slope, so for slope at this point you have to apply a unit moment, that is 1 kilonewton meter, or you can also take it q here. So q dot theta, this is q dot theta equal to, and here this value of p is 1, so the formula will be delta equal to this one. Okay, and here this value is also 1, so the formula becomes theta equal to 0 to L capital M small m dx upon EL. So these are the formula that you have to, will help you in calculating the deflection and slope in the unit load method. So let us start with a numerical, in which suppose this is a cantilever beam and there is one load that is 20 kilonewton, and here is one load that is 10 kilonewton. Okay, so this length is 3 meter, this is, you can take it 3 meters. Okay, so this is A, this is B, and this is C, and In this numerical, you have been asked to calculate the deflection at B point. So how will you calculate the deflection? I have already told you when you have been asked to uh, solve the numerical using unit load method, you have to apply a unit load at that point where you have to calculate the deflection. So while proceeding to the numerical, first of all, you have to calculate the reaction using the external loading. So for calculating the reaction, how many reaction will be here? This is a fixed support, so there will be three reaction. One is RA, that is vertical. This is HA, and one moment is here. Okay. Now calculate the value. So for that I am applying a equilibrium equation, that is summation fx equal to 0. So with this you will get HA equal to 0. So first equation is this one, summation Fy equal to 0. With this you will get RA minus 10 minus 20 equal to 0. I hope you are getting this point. Okay. So RA equal to 30 kilonewton. So from here you have calculated the value of reaction RA. Now for calculating the value of moment, summation of moment about A point is equal to 0. With this 20 into 6 minus 10, oh sorry, plus 10 into 3. So these are the two forces that will generate this moment, and one anti-clockwise moment is here, that is minus ma equal to 0. So from here ma will be 150 kilonewton meter. So now you have calculated the all the reaction. Now you have to apply a unit load at that point where you have to calculate the deflection. So this is the cantilever beam, and at B point you have applied a unit load. Okay, so this is A point, this is B point, and this is C point. This is 3 meters, this is 3 meter. Now calculate the reaction due to the unit load. This is VA, this is HA, and this is MA dash. You can take the other mm, naming values also. So I am taking HA dash here, MA dash, VA. So here you have to calculate the reaction due to unit load. So from here HA will be equal to 0 as per summation Fx equal to 0. Second equation of equilibrium is summation Fy equal to 0. From here you will get the value of Va equal to 1. And summation moment about A point equal to 0. From here you will get 1 into 6 and minus ma dash equal to 0. From here you will get ma dash value is equal to 6. Okay, so now you have calculated the reaction due to the external loading. Now you have calculated the values of reaction due to point or unit load. Now you have to make a table. Okay, in this table you have to mention that which member you are talking about, and what is the origin of that member, what is the limits till which you will be applying the integration, and then what is the capital M value, what is the small m value, what is the EI value. You can take all these values. Okay, so now I will be solving this. Let us take first member as BC. So write down the member here BC, and the origin of BC is B I am taking. So limit is 0 to 3. Okay, limit I have taken from 0 to 3 because BC length is 3. Okay, now for calculating the moment you have to take a section in BC from the origin. So origin is B, so from B I have taken X distance. Okay, so what will be the moment generated? Moment generated will be 20 into X due to the external loading capital M. Okay, and it is clockwise. and from right to left clockwise is negative. Okay, so negative I have taken. And in case of a small m, you have to cut the section in BC due to point load also. So and take distance x from B origin only. So now the equation will be here minus x. Okay, and EI is constant. Now take the second member, that is AC. Now I am taking AC. Now origin let us take A and limit will be 0 to 3. Okay. सो मोमेंट की वैल्यू देखिए, जो यहाँ पे से अगर मैं x डिस्टेंस मैंने AC पे कट किया है, अगर आप यही मोमेंट B से ओरिजिन लेके कट करेंगे तो आपको इक्वेशन थोड़ी लंबी पड़ेगी, बिकॉज वहाँ पे लोडिंग ज़्यादा है और यहाँ पर लोडिंग कम है। अगर मैं यहाँ से लोडिंग लूँगा तो वह मोमेंट की वैल्यू सेम ही आएगी, बट वहाँ पे क्या होगा, हमारे को लिमिट जो लगानी होगी इंटीग्रेशन में वो चेंज हो जाएगी। वो क्या होगी, लोअर लिमिट 0 नहीं होगी उसकी, अपर लिमिट लोअर लिमिट 3 से चलेगी और अपर लिमिट 6 तक चलेगी। तो उस केस में आपको इंटीग्रेशन करना थोड़ा टफ पड़ जाएगा। पर इस तरफ से मैं AC में चलूँगा तो लोअर लिमिट मेरी क्या है, 0 से 3 तक ही जाएगी। और हमें पता है बीम में किसी भी चाहे लेफ्ट टू राइट जाओ चाहे राइट टू लेफ्ट जाओ, किसी भी सेक्शन में तो मोमेंट की वैल्यू सेम ही आती है। सो हम इस तरफ से जाएंगे तो बेनिफिशियल पड़ेगा। AC में मैंने ए को ओरिजिन बनाया है, सो लिमिट 0 to 3 हो जाएगी। अब इसमें मोमेंट की इक्वेशन क्या होगी देखिए, अगर हम इस तरफ से जा रहे हैं x डिस्टेंस में, सो आर ए इंटू दिस डिस्टेंस, आर ए की वैल्यू क्या है 30। सो वी आर गोइंग नाउ लेफ्ट टू राइट, लेफ्ट टू राइट में आर ए कैसा मोमेंट जनरेट करा है क्लॉकवाइज, तो क्लॉकवाइज इज पॉजिटिव, सो 30 इंटू एक्स, और एंटी क्लॉकवाइज मूवमेंट है दैट इज -150। सो ये आ गई कैपिटल एम की वैल्यू। नाउ स्मॉल एम की वैल्यू के लिए भी आपको सेम सेक्शन यहाँ कट करना पड़ेगा, ए सी से जा रहे हैं तो एक्स डिस्टेंस भी यहाँ से कैलकुलेट होगा। सो वी ए की वैल्यू क्या है 1 माइनस जो मोमेंट की वैल्यू है, मोमेंट की वैल्यू कितनी है 6 एम ए, एंटी क्लॉकवाइज है क्योंकि सो 1 माइनस 6, 1 इंटू एक्स, ये तो 1 वी ए की वैल्यू क्या है 1 इंटू डिस्टेंस, परपेंडिकुलर डिस्टेंस है, सो 1 इंटू एक्स -6, तो ये आपकी होगी स्मॉल एम की, और ये आई क्या है कांस्टेंट है। अब जैसे ही आपने ये टेबल बना लिया तो आपको इंटीग्रेशन करनी है, सिर्फ वैल्यूज पुट करनी है। सो आप डिफ्लेक्शन कैलकुलेट करेंगे, सो डिफ्लेक्शन विल बी 0 to 3। अगर हम पहले मेंबर की बात करें, मेंबर पहला कौन सा BC के लिए लिमिट है 0 to 3, और फॉर्मूला है हमारा m इंटू एम, सो माइनस माइनस प्लस हो जाएगा, सो 20x² अपॉन EI प्लस 0 to सेकेंड मेंबर AC के लिए कितना होगा 0 to 3, और ये वैल्यू कितनी हो जाएगी 30x माइनस 150 x माइनस 6 अपॉन EI। अब आपको इसको इंटीग्रेशन करना है, इंटीग्रेशन करना बहुत इजी है। अब आप इसको जैसे ही आप इंटीग्रेट करेंगे आपको डिफ्लेक्शन की वैल्यू मिल जाएगी। सो डिफ्लेक्शन के लिए 0 to 3 जाएंगे तो यहाँ पे क्या आ जाएगा 20 अपॉन EI बाहर आ जाएगा, और यहाँ बचेगा x² dx प्लस 0 to 3। अब इसको मल्टीप्लाई करें आप, 30x² माइनस 180x माइनस 150x प्लस 900। ओके, सो ये हो गया हमारे 1/EI बाहर आ गया इसमें, और ये हो गया dx। अब आप इजीली इसको इंटीग्रेट कीजिए, 20 अपॉन EI और ब्रैकेट में आएगा एक्स क्यूब अपॉन 3, 0 to 3 प्लस 1 अपॉन ई आई बाहर है 30 एक्स क्यूब अपॉन 3 लिमिट लगेगी 0 to 3 माइनस you can calculate the values 0, 8 and 5 becomes 13, so it is x square upon 2. Okay, limit becomes 0 to 3 plus 900 x, limit becomes 0 to 3. अब इसमें आपको अपर लिमिट माइनस लोअर लिमिट लगा के डिफ्लेक्शन की वैल्यू कैलकुलेट करनी है and you will get this answer. So I hope you are getting this concept behind the unit load method. First of all, you have to calculate the unknown reactions, and after that, at what point you have been asked to calculate the deflection, you have to apply the unit load, and then you have to calculate the reaction due to that unit load, and then you have to make this table, and in this table you have to uh, write the limits properly so that you can easily calculate in the integration, and so that you can find out the moment value and due to the external loading and moment value due to the unit load value. So I hope you are getting this concept and start solving the numerical that are based on unit load method. You can solve the other numericals such as you have done Castellano's theorem, strain energy method. All the methods have been discussed. Now you have to solve the numerical. And if you are having any queries, you can ask me. So till now, thank you very much.